So we're here now for the third remote assignment, third remote video. And last time was homework number 39, page 476, 1 through 8 all, and 21 to 32 all. Guess what? I'm going to do a couple of those problems before we move on to the new material. So I'm going to do number 4, number 7, number 25, and then a couple others after that. So here we go. Let's start with number 4. Log base 2 of cube root m squared n. So here's the deal. I would make the third root into the 1/3 power. That's the first thing I would do. Make it just raised to the 1/3. I did nothing, didn't move anything around, just called the third root the 1/3 power. Now, what I would do next is distribute this 1/3 to both of these. That's what I'm going to do. In fact, let's do that. So it's going to be log base 2 of m to the 2/3 n to the 1/3, right? Because this times this to the power is this to the power, this to the power. That works fine. One other option you have here that I would not recommend is you could use the third law and pump the 1/3 out front right here and get 1/3 log base 2 of m squared n. But then when you split the multiplication up here into addition of logs, you better remember to use a parenthesis so you distribute that 1/3 to both of those. So as long as you remember that, you can do it that way, but be careful. I wouldn't recommend it. I would recommend doing it this way. That's how I would do it. Now, we've got multiplication, right? So I'm going to split that up into addition of logs. Log base 2 of m to the 2/3 plus log base 2 of n to the 1/3. Okay, and then finally, the third law of logarithms allows us to pump these numbers out front like this, and I get 2/3 log base 2 of m plus 1/3 log base 2 of n. And look, log base 2 of m, log base 2 of n, they're not raised to a power, they're not divided or multiplied. That is the answer. Okay, now, this one's kind of similar. Okay, I'd make that square root into the 1/2 power, log base 2 of m over n to the 3rd to the 1/2 power. So that's going to be log base 2 of m to the 1/2 over n to the 3/2. Now, the big picture here is division, log of division. So I could split that up into subtraction of logs. Log base 2 of m to the 1/2, which you could call that square root m if you wanted to now. I'm just going to do that in the next step. And then minus log base 2 of n to the 3/2, like that. So, now we've split up into subtraction of logs because it was division. Now I'm gonna, I'm sorry, I wouldn't call that square root of m because I'm trying to split up. I need to move this guy out front and this guy out front. So I would not call that square root m. That would not be the thing to do because you want to have it as a power 1/2 so you can move it out front here. So the answer would be 1/2 log base 2 of m minus 3/2 log base 2 of n. See, look, log base 2 of m by itself, log base 2 of n by itself. This is the great and mighty answer. All right, now this one is one of the ones that in the last video I showed you is a little bit trickier. Definitely trickier than these guys, okay? It's starting split up and we're going to try to squeeze it together. That's not what makes it trickier. What makes it trickier is this 3 right here. So, obviously log base 2, they can be combined together. But this 3 cannot be combined together with log base 2's unless it is a log base 2 itself. So, what do I have to do? I have to figure out how can I write 3 as log base 2 of something, right? So here's the deal. Log base 2 of what gives me 3? Well, if you understand the basics of logarithms, right? This number to this power has to equal this number, so this has to be log base 2 of 8. That's how I can write 3 as log base 2 of something. It's log base 2 of 8 because 2 to the third power equals 8. So, since this is the same as this, I could use substitution. I could replace this 3 with log base 2 of 8 by substitution, and that gives me the beautiful thing, log base 2 of m plus log base 2 of n plus log base 2 of 8, right? I replaced 3 with log base 2 of 8. Now, they're all log base 2's, so I can squeeze them together into a single log base 2. And look, they're all addition, right? So it's going to be m times n times 8. Now, if we want to go m times n times 8, we generally aren't going to write it as m n 8 because that's not how that would look weird. M n 8. Is that how we usually write 8 times m times n? No. What we usually do is put the number out front, so we're going to call it 8mn. That just looks more normal. It really means the same thing as this, but that looks weird. This looks normal. There we go. That's the answer. Okay. Hopefully you understood that. That was the trickiest part out of all of this, I think. Now let's go to another one. Actually, we're going to do a couple more kind of like that. I just want to make sure you got these ideas down. So let's find some more. I can fast forward to where we're at. Okay. Okay, this one right here, number 26. That was number 25, right? 26 says it's a similar kind of problem. Log base 5 of x minus log base 5 of y plus 2. So look, the plus 2 hanging out there is what's going to mess us up, just like the 3 messed us up over there. So we need to write 2 as log base 5 of something. So log base 5 of what gives me 2. Hopefully you guys can figure that out now. Look, this base to this power has to be this, so this has to be 25. So I can write 2 as log base 5 of 25, which is exactly what I'm going to do. Let's see. So I'm going to get log base 5 of x minus log base 5 of y plus log base 5 of 25. And then, very similar to the last problem we did, it's going to be log base 5 of x. We can squeeze them all together. Now, this is positive, right? So x is going to be up on the top. This is minus, so the y is going to be in the bottom. And the 25 is also positive out front, so it's going to go up top. So I've got the 25 and the x upstairs. I've got the y downstairs, and that is the answer. Okay, it's very similar to 25. Okay, 27 is similar, but I did want to do this one because I wanted to show you one thing. Some people might not be as familiar with 1 or may get confused by how do I deal with the number 1. Well, I will show you how you deal with the number 1. It's the same as with any other number, really. Okay? At 27, it goes 1 minus 3 log base 5 of x. Okay? So, if I want to squeeze these together, right? This guy's a log base 5. Now, I can clearly pump this 3 up and make that x to the third and get this log base 5. But what about this guy? Well, I need it to be log base 5 so that I can combine these together. So I have to say log base 5 of what gives me 1. I have to replace 1 with log base 5 of something. Well, look, simple, look. Log base 5 of what gives me 1? Well, 5 to the first power is 5, right? So it's log base 5 of 5. And that's that for any time it's a 1 here. If this was log base 8, it'd be log base 8 of 8, right? Log base 10 of 10, whatever. It's log base number of that same number is going to give you 1. That's how it works. So log base 5 of 5 minus log base 5 of x to the third. Now this is subtraction, so it's going to be division of logs, because that's the second law. log base 5 of 5 over x to the third, and there you go. So that's 27, and then 28. I also wanted to do that one because this one isn't quite as obvious as the rest of them, how to do it, even though it really is pretty much the same thing. Here we go. So 28 looks like this. 1 plus log base 9 of x over 2. Well, what do you do with that? Oh my gosh. Well, here's what you do. Here's what I would recommend. I would split this up into 1/2 is the number, it's just a number, plus, now you could call this log base 9x over 2, or you could call it 1/2 log base 9 of x. That's probably the easiest way to do this, right? So look, log base 9x over 2 dividing by 2 is the same thing as timesing by half. I'm calling it 1/2 times log base 9 of x. Why am I calling it that instead of log base 9 of x over 2? Because then I can pump this half up as the exponent right there. And then what happens to this half though? Wait a minute, I need to make it, now this is gonna take a little bit of thinking, so stay with me here, okay? I need to write, ooh, I don't like that color. Yeah. Let's get a better color, okay? I need to write log base 9 of something. I need to write that as 1/2, right? I need to replace 1/2 with log base 9 of something. So 9 to the half power. Remember what half power is? Just square root. 9 to the half power is square root of 9, which is 3. So I would have to replace 1/2 with log base 9 of 3. So log base 9 of 3 plus log base 9 of x to the 1/2, which is square root x. I'll call it square root x in the next step, right? So that's log base 9 of 3 times square root x, because addition of logs combines into multiplication here. Cha-ching. Okay, now, oh, I forgot about those type. Those are the ones that just turn out to be actual numbers. So let's do that. Those are kind of fun. Those are very useful in life. So I know I use them all the time. Okay. So here we go. 2 log base 10 of 5. 2 log base 10 of 5 plus log base 10 of 4. And this happens to be number 29. So, first thing I would do here is pump this 2 up as an exponent. So you get log base 10 of 5 squared, or 25, plus log base 10 of 4, right? Well, that's going to be log base 10 of, since this is addition, you multiply this. 5 squared is 25, right? So it's 25 times 4, right? Well, that's going to be log base 10 of 25. That's 100. 10 to what power gives you 100? 2, baby! 2! Okay, all right. There we go. There we go. All right. Wow. I like that. So, if your mom says, hey, how many helpings of my biscuits and gravy would you like? You tell her this many. Okay, there you go. Okay, see? Very useful. Okay. Okay, one more, very similar, 31. Log base 4 of 40 minus log base 4 of 5. What? This one seems too easy. But wait, let's see. That's going to be log base 4 of 40 divided by 5. Well, that's 8. Log base 4 of 8. Wait a minute. 4 to what power is 8? Well, not a nice power, but it's going to not be too bad. Let's see. What? Log base 4 of 8. 4 to what power is 8? I'm not quite sure. In fact, you might even say that I'm somewhat in doubt. I've got a question. When I'm in doubt, what do I shout? Convert or eat dirt. But first of all, let's give it a name. Let's call it, say, act. Now I'm going to convert. No dirt. Here we go. So this base to this power, 4 to the x power equals 8. Now, these are not the same base, but I can make them powers of the same base. They're both powers of 2. So I can make it 2 to the squared to the x equals 2 to the third. And then that's 2 to the 2x equals 2 to the 3. Now I set them equal. They have the same bases. I could throw away the bases. 2x has to equal 3, but I don't want 2x. I just want regular x, so I divide by 2. X is 3/2, and there you go. That's what it is. So if you're on the football team and your jersey number is 3/2, there you go. Right. Not bad. Okay. So that takes care of that. That's yesterday's homework. So hopefully if you had any trouble, that helped. Let's get on to today's news material. The new material is exciting. I like it. You'll like it probably. It's called Solving Logarithmic Equations. This one is a pretty good topic, pretty important, and not too bad. You have to know that there are 2 types of logarithmic equations. I'll get into that. It's very simple. First of all, what is a logarithmic equation? A logarithmic equation is an equation that contains a log, okay? Simple enough. A logarithmic equation is an equation that contains a log, okay? Good enough. That's the first part. That's how you know. So if it doesn't have a log, it's not a logarithmic equation. If it is a logarithmic equation, it will have a log. Now, it has one of 2 types. Okay, say we have an equation right here, right? It's either going to have a log on one side with blah, 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 and not a log on the other side, so a log on one side, or it would have a log on this side and a log on this side. So, if you have a logarithmic equation, there's either going to be a log just on one side and not the other, or you're going to have logs on both sides, right? One or the other. It has to be that. If it's a logarithmic equation, it's either going to be this type or this type, okay? Well, here's the deal. You solve them differently. So, what you do is if it's, well, we'll get into it. Let's start solving them, and then you'll see what we do. So, it matters if they're on both sides or just one side. That's the first question you want to ask yourself. Is it on both sides or is it just on one side? And that tells you basically what to do. So here we go. Let's do our first problem. Okay, here we go. Log base 3 of x plus log base 3 of x minus 6 equals 3. Okay, there's our first logarithmic equation. Now, does this have logs on one side or both sides? If you look, you might say, well, there's 2. And I say, no, there's 2, but look, here's the equation, right? This equation, here's the equal sign. This equation has logs on this side, but not logs on this side, right? So this is the kind that just has it on one side, not both sides, right? So what can I do? I'll show you what we do to solve it, okay? First of all, we use the laws of logarithms to squeeze it together. If they're split up like this, we want to squeeze it together into a single logarithm. So here we go. We go log base 3 of x times x minus 6, right? See, we turn the addition of logs into log of multiplication equals 3. So all I did is squeeze those together into the single logarithm. Log base 3 of this equals 3. And then I say, dang it! I'm not sure what to do. In fact, you might even say I'm in doubt as to what I should do. Well, I got a question. Let's see, I bet I can make it come up here. When in doubt, what do I shout? Convert or eat dirt. Let's see, I'm going to convert. Okay, so look, this base 3 to this power 3 equals this thing, x times x minus 6. That's how you can do that. You convert it. Now, 3 to the 3, hopefully you know, is 27. You should know that. 27 is, if I distribute the x, I get x squared minus 6x. Now, that is a second degree equation, a quadratic equation, right? You can solve this by factoring or a quadratic formula or even completing a square. Personally, if it factors, that's the one I like to use the best. Now, they don't always factor, but a lot of times they do. Like in this case, this one factors. X, two numbers that multiply to be 27 and subtract to be 6 would be 9 and 3. Different signs, bigger one minus, this one's minuses. You guys should be very familiar with that. We did that last semester, factoring polynomials. And then, so now x minus 9 is 0 or x plus 3 is 0. So x is positive 9, which would make that 0, or negative 3, which would make that 0. So my two potential solutions are 9 and negative 3. Now, are those potential or actual? They are potential. Because here, this is a very important thing. I told you this before, you may or may not remember it, but the argument of the logarithm, this x right here, and this x minus 6, has to be positive. It cannot be 0, cannot be negative. So, it's very important when you're solving logarithmic equations that if you get whatever answer you get, you need to plug it back into your original equation and make sure it doesn't make any of the arguments negative or 0. They have to always be positive. So, you go back in one by one. Don't do them at the same time. Let's start with 9. Log base 3 of 9, so that makes that positive. 9 take away 6. That's also positive. So 9 is good. 9's a good solution. What about negative 3? Negative 3 is going to make that guy negative. It would also make that guy negative. Now, it doesn't matter that it makes them both negative. If it makes any of them negative, it's a bogus solution. So we got to throw it out. This one is a bogus solution. Okay. So the correct answer, the potential solutions were 9 and negative 3. The correct answer is 9 because negative 3 turned out to be a bogus solution because it makes an argument, or in this case, both arguments of a logarithm negative, which we don't want. Right on. Okay, no, I'm not done yet. Okay, so here we go. Now look at this one. Log base 3 of x equals 3/4 log base 3 of 16 minus log base 3 of 4. What do you have to do? Well, you squeeze them together into one logarithm, right? These guys are split up, right? This guy's on the other side, so you don't put this into the single logarithm, right? But this guy, it's split up over on this side. Squeeze them together. So that's what we got to do. Wait a minute. I don't know why I put the 3/4 there. I need to pump the 3/4 up as an exponent. Okay, so it's going to be log base 3 of 16 to the 3/4 minus log base 3 of 4. Okay. Now I'm going to simplify 16 to the 3/4 power. Okay, I'm going to talk it through this. You guys should be able to figure that out. 16 to the 3/4. That's the fourth root of 16, which is 2 to the third power, which is 8. 16 to the 3/4 power is 8 minus log base 3 of 4. Okay, now log base 3 of this minus log base 3 of this squeezes together into division. Log base 3 of x is, squeeze them together, log base 3 of 8 divided by 4, which is 2. And now, just like when we had 2 to the power equals 2 to the power, and we could throw away the bases and set the powers equal to each other, look, log base 3 of x equals log base 3 of 2. Guess what you can do? You can drop the logs, and x equals 2. You just get these guys, the arguments equaling each other. That's how you do it. So if you have the logarithmic equations that have just log on one side, what do? Convert. Squeeze it together first though. Squeeze it together and then convert, right? What happens if they're on both sides? Squeeze them together, drop the logs. Got it? Okay, that's the deal. So we're going to do a few more like that. That's how it works. Okay, let's do this one. These are fun. Okay, here we go. Log base 8 of x plus 3. So log base 8 of x plus 3 plus log base 8 of x equals log base 8 of 4. Okay, there we go. Now, first thing I'm going to do, there's nothing to pump up. There's no number sitting out here I need to pump up as powers. So I'm going to squeeze these guys together right here. I'm going to get log base 8 of x plus 3 times x equals log base 8 of 4. Now, log base 8 of this equals log base 8 of that. So what do? Drop the logs, and I get x plus 3 times x equals 4. Oh my gosh. So I just distribute the x squared plus 3x, might as well minus 4 from both sides. So minus 4 equals 0. There's my quadratic equation. Hopefully I can factor it. Most of these you'll be able to factor. It's possible there might be one or so that you can't, but most of them end up factoring. So this is 4 and 1. Two numbers that multiply to be 4 and subtract to be 3. 4 and 1. Different signs, bigger one plus. This is plus, this is minus. So x is negative 4 and 1, which are my solutionalis potentialis, right? So let's see if they're actually good solutions or bogus. Well, let's start with negative 4. Negative 4 plus 3 is negative 1. Can't be negative. Negative 4 is a bogus solution. Okay? Actually, it would make this also negative, but it doesn't even matter. Because if it makes any of them negative, you can throw it out. Now, wow, the one has to be work because it's a positive number. Not necessarily. What if this was a x minus 3 instead of a plus 3, for instance, right? Then you'd go, if it was 1 minus 3, then even that positive number 1 would end up making this negative if that happened to be a minus 3. So a positive number could end up being a bogus root. So it just depends. But a negative number is very likely a negative root. A bogus root. It just depends. You got to check it out. Okay. So that one's bogus. Let's try 1. 1 plus 3 is 4. That's positive. That's good. 1 is positive. That's okay. So everything looks good there. So the correct answer is x equals 1. Negative 4 was a potential solution, but it's bogus. Okay. Truck it away. Okay, here we go. Oh, look how nice they are being to us. We don't even have to squeeze anything together here. Look, they've already got my equation. It's an equation with log just on one side, not on both sides. So when it's on one side, I squeeze it together, which it already is. So now I just convert, or I can eat dirt, but I'd rather convert. So here we go. This base to this power equals this. So 2 to the third equals x plus 1 to the third. Whoa, whoa. 2 to the third equals x plus 1 to the third. Well, wait a minute. The overall quantities are equal. And the powers are equal. That must mean the bases are equal to, especially since this is an odd root. Now, if it was an even root, then they could be, you'd have to use plus or minus, but this is an odd root, so there's only one way to get it. So if 2 to the third is the same as x plus 1 to the third, 2 must be the same as x plus 1. So x plus 1 equals 2, minus 1 from both sides. You get 1 equals x, right? 1 equals x. So we can even check your answer. Look, 1 plus 1 is 2, right? 2 to the third power is, look, 2 to the third power equals 2 to the third power. Yeah, checks out. It's a good solution. So there we go for that problem. Hang in there. You just got a little more to go. Okay, there's another one. These are fun. I love these. I love doing these equation ones. These are better than a lot of stuff. So hope you guys enjoy them. Here we go. Log base 4 of x plus 4. Log base 4 of x plus 4. Minus log base 4 of x equals log base 4 of x plus 1. Okay, clearly, we're going to have to squeeze some together here. So I'm going to do that. So we're going to get log base 4 of this guy divided by this guy. So x plus 4 over x equals log base 4 of x plus 1. Okay, so log base 4 of that equals log base 4 of that. Guess what? Drop the logs. And here we go. X plus 4 over x equals x plus 1. Okay, let's look at this. Ooh, yuck. X in the denominator. Bad. I don't like that. You probably don't like that. How can we get it out of there? Easy. Just times by x. But if you times this side by x to cancel that, you have to also times this side by x. So I get x plus 4 equals x squared plus x. Is that right? Yeah, that's right. Okay, then I need to solve for that. There's x squared, right? So I'm going to make this side 0. Remember, you want to make one of the sides 0. And you go 0 equals x squared. This cancels. Oh my gosh, it's a dog. Oh my gosh. So it's the difference of squares, right? X plus 2, x minus 2. So x is negative 2 and regular 2, which are my potential solutions. We got to see, do they work? So you go back up here, negative 2. Negative 2 plus 4 gives me positive 2. So there's a situation where a negative number still works okay here, but it doesn't work here, so it makes it no good, right? And then negative 2 plus 1 would also make that negative, so it's no good. But it did work over here. If we didn't have these guys in the problem, then it would turn out to be a good solution, but it's not because of these guys. So negative 2 does turn out to be bogus. And then how about positive 2? 2 plus 4 is 6, that's good. 2, that's good. 2 plus 1 is 3, that's good. They're all positive. So 2 is a good solution. Okay. Okay, let's see what the next one is. Okay. I'm doing a lot of these because I think it helps to see several of them and kind of see how to do them. So I know I'm doing quite a few, but I think it helps you understand. Okay, so here we go. Who cares that it's base B? We're going to throw away the bases anyways, so it doesn't really matter. So anyways, it's addition, so I can make that into log of multiplication. So 3x plus 2 times 9 equals log base b of x plus 5. So see, it doesn't really matter. At this point now, we're gonna throw away the log base b's, and we're gonna get 3x plus 2 times 9. I'm gonna distribute the 9 while I'm doing it and call it 27x plus 18, that's just this kind distributed out, equals x plus 5, because I threw away the bases. Oh my gosh, this is like Algebra 1, first semester, right? Yep, minus x. I'm moving the x's over here, might as well move the numbers over here, and I get 27 minus 1 is 26x equals, this cancels, and I get negative 13. Now, whoa, look at that. Ooh, negative 13, negative Dan Marino, how about that? So wait a minute, negative 13 and 26, so it must be negative 2, right? Wrong, it's not negative 2. In fact, it matters what you are divided by. Look, I have 26 times x. I want x by itself. So what do? I divide by 26 and I get 13 or negative 13 over 26, which is not 26 over negative 13. It's not 2. In fact, it's x equals negative 1/2. So be careful. Sometimes people will get all the way to here and see 26x and 13 and think, oh, negative 2, because 13 goes into 26 twice, but that is not correct. It's negative 1/2. Now, wait a minute, I put a box around it, which shame on me, because I shouldn't yet, because I don't know if it's an actual solution or a bogus solution, okay? Well, let's see, let's put in negative 1/2. 3 times negative 1/2, that's negative 3/2, which is negative 1.5, plus 2 is positive 1/2. So, whew, yes, it's positive still, barely, but it is, okay? Negative 1/2 plus 5 is still positive, right? So guess what? It is a good solution. Even though it's a negative number, it is a good solution. Now, what if it wasn't? What if my only solution turned out to be bogus? Then it would just be no solution. That can happen. All right. We're doing logarithmic equations. Can you believe it? Okay, this is the last one I'm going to go over with you guys. There's a problem like this in the homework. If f of x is log base 7 of x, so f of x is log base 7 of x, find f of 49, okay? Find f of 49. Now, what does f of 49 mean? It means you go to the function f, wherever you see an x, you replace it with 49. That's what it means. So f of 49 just means log base 7 of, replace that x with 49, log base 7 of 49. This means 7 to what power gives you 49? And the answer is 2. That's how that works. That's function notation. That's, evaluating functions. So, there you go. Let's see. So, there's the homework. Page 476, written exercises, 33 to 42 all, 45 to 51 all. On number 41, only do parts A and B. You do not have to do part C. Actually, that should say at 33 to 41. I'm not having you do problem 42. So it actually should say 41. I better change that. So I'll make sure I change it when I let you know about it, when I assign it or whatever. So it's actually 41. Let me fix it. There we go. That's the actual correct assignment. And on number 41, you don't have to do you only have to do parts A and B. Part C involves the inverse of the function, and I haven't really shown you how to do that. So don't worry about part C on 41. Have a good one.